Hi everyone. Today we're going to be looking at how to identify the cations, mainly metal ions, in solution. The first test we're going to try is simply to add some sodium hydroxide and some ammonium hydroxide solutions to your unknown liquids. We'll start with copper. Now, copper solutions are generally easy to identify anyway, as they're usually blue or sometimes green. As you can see, adding a few drops of sodium hydroxide gives a blue precipitate of copper 2 hydroxide. Adding more just produces more precipitate. A few drops of ammonium hydroxide has the same effect. Copper 2 hydroxide is produced. But this time, on adding excess, the precipitate dissolves, producing a deep blue solution. The colour of copper solutions is due to the copper ion forming a complex with water molecules, which is pale blue. Ammonia can displace the water and produce an amino copper complex, which is dark blue. Next we'll look at iron. Iron has two common forms, iron 2 and iron 3. We'll start off with iron 2. Solutions of iron 2 compounds are usually pale green, like the iron 2 sulfate here. On addition of a few drops of sodium hydroxide, you get a dark green precipitate of iron 2 hydroxide. On adding excess, as with the copper, you simply get more precipitate. With ammonia, unlike copper this time, the reaction is exactly the same as for sodium hydroxide. Dark green iron 2 hydroxide is produced, which doesn't dissolve. Iron 3 compounds produce yellow or orange solutions. This time, sodium hydroxide produces a reddish-brown precipitate of iron 3 hydroxide, which too does not dissolve in excess alkali. And as with iron 2, the effect of ammonia is exactly the same as the sodium hydroxide. Aluminium compounds, like many others, give a white precipitate. On adding excess, with a little bit of stirring, you can see that this time it dissolves. Aluminium hydroxide is amphoteric, and in this case it reacts with sodium hydroxide to form soluble sodium aluminate. In ammonia, you still get the precipitate of aluminium hydroxide, but ammonia is not as strong a base, and this time it does not dissolve. Zinc too gives a white precipitate of sodium hydroxide that also dissolves in excess. This time though, it will dissolve in excess ammonia. This is due to a similar reaction to that with the copper, zinc ions forming a soluble amine complex. Magnesium, like the previous two, gives a white precipitate. This time it won't dissolve in excess sodium hydroxide. With ammonia, this time the white precipitate remains when you add excess. Magnesium hydroxide is not amphoteric and does not form a complex either. Calcium compounds behave in exactly the same way as magnesium, as long as the concentration is fairly high, as calcium hydroxide does dissolve a little in water. In fact, it forms lime water. And like magnesium, it forms the same white precipitate in ammonia that does not dissolve in excess. Solutions of lead compounds behave in the same way as aluminium. With sodium hydroxide you get a white precipitate that dissolves in excess. Lead hydroxide is amphoteric, and with ammonia you get the same white precipitate, but it does not dissolve. So you can see that this pair of tests is actually quite good for differentiating many cations, but there are some that need further investigation. Aluminium and lead, and magnesium and calcium both behave in the same way as each other. And then of course there are some compounds that do not give a precipitate at all. Sodium, potassium, barium for instance, and these will be covered in the next video.